Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 29 video on the chapter of mensuration, where I will solve question number 11 to question number 20 of exercise 20G from the chapter of mensuration from the textbook of author RS Aggarwal. If you have not watched the previous videos, part 1 to part 28, where I have discussed and solved the concepts of area and perimeter of rectangle, square, circle, parallelogram, rhombus, then I strongly suggest that you also watch those videos to maintain the continuity of your study on this chapter. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 29 video on the chapter of mensuration, where I will solve question number 11 to 20 of exercise 20G from the chapter of mensuration. Okay, so I have written down all the questions 11 to 20. I don't know the answers. I hope I will come up with the correct answer, correct solution. If you see that I am solving any question incorrectly, then please feel free to let me know in the comment section. But your focus must be how I am applying the formulas and the concepts to solve the problem. Okay. So question number 11 says the sides of a triangle measure 13 centimeter, 14 centimeter and 15 centimeter. Its area is. So we know that when we are given the length of the sides of a triangle, to find its area we must apply the Heron's formula. So we know the Heron's formula is area A of a triangle is square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C, where ABC are the length of the sides of the triangle, and small s is the semi-perimeter, which is half of A plus B plus C. A plus B plus C is the perimeter of the triangle, so semi-perimeter means half of it. So for this problem triangle, the semi-perimeter will be 13 plus half of 13 plus 14 plus 15, this much centimeter, which is equal to 27 and then 42. So this is 21 centimeter. So the area will be square root of S is 21, and then we have 21 minus 13, 21 minus 14, 21 minus 15, this much centimeter square. So this is equal to 21 multiplied by 21 minus 13 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. This much centimeter square. Now inside we have to, so we have some product of integers inside the square root. We have to form a perfect square inside the square root. Then it will be, then we can easily find the square root. So 21 is 7 multiplied by 3, and 8 is 4 multiplied by 2, and we have 7, and 6 is 2 multiplied by 3. So this much centimeter square. So I have just factorized all the numbers, that is 20, 21, 4, 8 and 6, so that I can form a perfect square. So I see 7 into 7, which will be 7 square. I see 3 into 3, that will be 3 square. 4 is 2 square, or else I can say 4 multiplied by 2 multiplied by 2 is 16, which is 4 square. So this much centimeter square. So this will be now 7 multiplied by 3 multiplied by 4, this much centimeter square, and this is equal to 84 centimeter square. So the correct choice is A. A is the correct choice. So this problem was based on direct application of Heron's formula to find the area of a triangle whose length of sides are given. Question number 12. The base and height of a triangle are 12 meter and 8 meter respectively. Its area is. So this is a direct application of the area of a triangle, direct application of the formula of area of a triangle as half into base into height. Now the base can be, you can consider any side of the triangle as the base, and the corresponding height will be the perpendicular distance of the length of the perpendicular drawn from the opposite vertex on that side. Now in this problem, the value of the base and height are directly given. So area will be half into base. Base is given to be 12 and height is given to be 8. So this much meter square, since the units of base and height are in meter. This is equal to 2 divides 8 with 4. So this is 48 meter square. So the correct choice is B. B is the correct choice. Okay, let's see the next problem. Question number 13. The area of an equilateral triangle is 4 root 3 centimeter square. The length of each of its sides is. So we know that for an equilateral triangle, the area of an equilateral triangle where the length of each side is A is square root of 3 divided by 4 multiplied by A square. This is the formula. Okay. Now this implies in this problem the area of the equilateral triangle is given to be 4 square root of 3. So we have 4 square root of 3 is equal to square root of 3 divided by 4 A square. By doing cross multiplication, I will get A square. So 3 square root of 3 you can cancel out from both the sides, or I can say I can divide both the sides, both LHS and RHS of this equation by square root of 3. I can cancel out square root of 3. So I get A square is equal to 16. This will be 16 centimeter square. So this implies A will be square root of 16 centimeter, which is 4 centimeter. So the length of each side of the equilateral triangle is 4 centimeter. So the correct choice is B. B is the correct choice. Let's see the next problem. Question number 14. Each side of an equilateral triangle is 8 centimeter long. Its area is. So again, we know area is equal to square root of 3 divided by 4 A square, where A is the length of each side of the equilateral triangle. So the length of each side of the equilateral triangle is given to be 8 centimeter. So the area will be square root of 3 divided by 4 multiplied by 8 square, this much centimeter square. This is square root of 3 by 4 multiplied by 8 multiplied by 8 centimeter square. 4 divides 8 with 2. So this is equal to 16 square root of 3 centimeter square. So the correct choice is choice C. Let's see the next problem. Question number 15. The length of an equilateral triangle is square root of 6 centimeter. Its area is. So this problem is exactly similar to question number 14. Okay. So area we know for an equilateral triangle is square root of 3 divided by 4 A square. The length of each side of the equilateral triangle is given to be square root of 6 centimeter. So the area becomes square root of 3 divided by 4 multiplied by A is square root of 6. So this square, this much centimeter square. This is equal to square root of 3 divided by 4 multiplied by square root of square root of 6 is 6. This much centimeter square. And if I simplify this, this will be 3. Its area is 2 3. This is 3 root 3 divided by 2 centimeter square. The length of an equilateral triangle is, it is coming 3 by 2. 3 by 2. 3 by 2 square root of 3 centimeter square, but there is no choice as 3 by 2 square root of 3. I will quickly check whether I have copied the question correctly or not. Question number 15, the height, question number 15 is oh sorry, it is the height, it is not the length but the height. This will be height. The height of an equilateral triangle is square root of 3 centimeter, then its area is, okay, so in that case my solution is wrong. So height of an equilateral triangle is given and we have to find its area. Now you must be familiar, you must know what is the relation between height of an equilateral triangle and each side. So height h, so if this is an equilateral triangle, if this is an equilateral triangle of each side of length a, then the height of an equilateral triangle is same. That is, since there are in a triangle there are three heights, considering which base, considering the three sides as the base, but since this is an equilateral triangle, all the heights, that is the perpendicular distance from any vertex to the opposite side, is same. And if height is h, then using Pythagoras theorem, I think height will be equal to square root of 3 by 2a. This is the relation between the height of an equilateral triangle and the length of each side, that is a. But let me quickly check if I am correct or wrong. Applying Pythagoras theorem, I must have a square is equal to, now this perpendicular will bisect the base, so this length and this length, these two both will be a by 2. So we will have a square is equal to h square plus a by 2 squared. This is h square plus a squared by 4. So this implies h square is equal to a square minus h square by 4. This is 3a square by 4. So this implies h will be square root of 3 by 2 into a. So remember, this is an important relation. You must always remember that the height of an equilateral triangle is equal to square root of 3 divided by 2 and a. So this height is given and we have to find its area. Okay, now what is area? Area we know is square root of 3 divided by 4 a square. And what is a? From this equation, h is equal to root 3 by 2 a. We can say that the area will be square root of 3 divided by 4 multiplied by what is a? A will be 2h by square root of 3 and square. This is equal to, so you must also be familiar with the relation between height and the area. We know that in an equilateral triangle, area is equal to square root of 3 divided by 4 a square. This is the relation between area and the length of each side. You must also be familiar with the relation between the area and the height of an equilateral triangle. So that's what I am trying to derive. So this will be square root of 3 by 4 multiplied by 4h square by square root of 3. 4 cancels out and we have the square root of 3 cancels out. So this is height square. Quite interesting. So area of an equilateral triangle is height square. I was not aware of this. So if this is so, area, no, I am wrong, because the height of the equilateral triangle is given to be square root of 6 and the square root of 6 is 6. There is no choice, 6. Let me quickly check whether I have hit whether a is equal to h square or not. 3. Okay, so I did a mistake. 2h by square root of 3 whole square is 4h square by 3, not a square root of 3. So this is 3. So this becomes h square by square root of 3. So the area of an equilateral triangle is h square by square root of 3, where h is the height of the equilateral triangle. So this is also an important formula you should remember. So area for this problem will be square root of 6 square of square root of 6 divided by square root of 3, which is equal to square root of 6 is 6 by square root of 3. If I multiply both the numerator and the denominator with 3, I will get square root of 3. I will get 6 square root of 3 divided by 3, 2. This is 2 square root of 3 centimeter square. So the area will be 2 square root of 3 centimeter square. So the correct choice is B. So for an equilateral triangle, it is very important that you must know the relation between the area, the height, also the perimeter and the length of each side of the equilateral triangle. So we know area A is equal to square root of 3 divided by 4a square. Also area is equal to h square by square root of 3, where h is the height of the equilateral triangle. Okay, let's do the next problem. One side of a parallelogram is 16 centimeter and the distance of the side from the opposite side is 4.5 centimeter. So basically the base and height is given. So if you consider any parallelogram, let's say this will be a parallelogram. If we consider this to be the distance of this, the length of this side, let's say ABCD be the parallelogram. Let's say the length of BC is given to be 4.5 centimeter, and so it is given that one side of a parallelogram is 16 centimeter and the distance of this side from the opposite side. Now the opposite side to BC is AD, and the distance between BC and AD is nothing but the perpendicular drawn from any vertex either B or C on AD. So if CE be the perpendicular to AD, then CE is the perpendicular distance between the opposite sides BC and AD, so which is also the height. So we know that for a parallelogram, the area formula of area is base into height. Now base can be any one side, and the height is the distance, the perpendicular distance between that side and the opposite parallel side. So in this problem, the base is given to be 16, and the bay height will be 4.5. So this much centimeter square. So this is equal to, I will use calculator for doing some calculation to save time. 16 multiplied by 4.5 is 72. So this is 72 centimeter square. So the correct choice is choice B. So this problem was direct application of the formula of area of a parallelogram, which is base into height. Okay. Question number 17. The lengths of the diagonals of a rhombus are 24 centimeter and 18 centimeter respectively. Okay. Its area is. Okay. So we know that for a rhombus, the formula for area of a rhombus is half into product of the diagonals. That is, if I consider D1 and D2 be the length of the two diagonals of a rhombus, the formula of area is half into D1 into D2. So in this problem, D1 and D2 are given to be 24 centimeter and 18 centimeter. So the area will be half multiplied by 24 multiplied by 18, this much centimeter square, and this is 12. So 18 multiplied by 12 is 216. So this is 216 centimeter square. So the area of the rhombus is 216 centimeter square. So the correct choice is B. B is the correct choice. So this was also a direct application of the standard formula for area of a rhombus, which is half multiplied by the product of the two diagonals, length of the two diagonals. Question number 18. The difference between the circumference and the radius of a circle is 37 centimeter. The area of the circle is, okay. So let's see, we know that circumference for a circle C is 2 pi r, where small r is the radius of the circle. So what is given? It is given that the difference between the circumference and the radius, okay, so C is the circumference. The difference between circumference and the radius is C minus r. This is equal to C, we know, is 2 pi r. So 2 pi r minus r is given as 37 centimeter. So this implies 2 pi r minus r. If I take r common, I have r multiplied by 2 pi minus 1. This is 37. Okay, so this implies whenever nothing is mentioned in a problem, you must always consider the value of pi to be 22 by 7. So this is r. 2 into pi is 2 into 22 by 7 minus 1. This is equal to 37. Now remember, the problem is asking the area of the circle. Okay, the area of the circle. Okay, the area of the circle will be pi r square. Okay, let's see. So this is equal to r. Let's simplify. So this is 44 by 7 minus 1 is equal to 37. So this implies 44 by 7 minus 1 is 37 by 7. So this is 37 by 7. R is equal to 37. So this implies R is equal to 7 by 37 multiplied by 37, this much centimeter, which is equal to 7 centimeter. So the radius of the circle is 7 centimeter. So this implies area is equal to pi r square, which is equal to pi is 22 by 7 and r we have found to be 7 centimeter. So 7 multiplied by 7, this much centimeter square, which is equal to 154 centimeter square. So 154 centimeter square is the area of the circle. So the correct choice is C. C is the correct choice. Okay, let's see the next problem. The perimeter of the floor of the room is 18 meter and its height is 3 meter. What is the area of 4 walls of the room? What is the area of 4 walls of the room? Now, what is the area of the 4 walls of the room? I forgot the formula. Half multiplied by area of the 4 walls of the room. There are 4 walls. Okay. What was the formula? Let me quickly open my quick notes and I'm just referring my quick notes for the area of the 4 walls of a room. Area of floor. Okay. Area of 4 walls is 2 into length plus breadth multiplied by height. So 2 into length plus breadth of the room and multiplied by height. We know that a room has a 3-dimension length, breadth and height. And the perimeter of the floor of the room, so P, let's say floor, perimeter of the floor is nothing but 2 into length plus breadth. So this is the perimeter of the floor. Okay. So we can say, so the problem is asking what is the area of four walls of the room. So let's say A walls, B denote the area of the four walls of the room, whose formula is 2 into length plus breadth multiplied by h, that is the height of the room. But length 2 into length plus breadth, which is also equal to, you can consider 2 into length plus breadth is nothing but perimeter of the floor. So perimeter of the floor multiplied by h is the area of the four walls of the room. So in this problem, the perimeter of the floor of the room is given to be 18 and the height is given to be 3. So the area of the four walls of the room becomes 18 multiplied by 3 meters square, which is 54 meters square. So this is an important concept. You must remember that we know that the area of the four walls of a room is equal to 2 into length plus breadth multiplied by height. Where small l is the length of the room, small b is the breadth of the room, and h is the height. But also note that 2 into length plus breadth, 2 into l plus b, that is the perimeter of the floor of the room. So the area of the four walls of the room becomes perimeter of the floor multiplied by h. Okay, let's see the next problem, the last problem in this video. Question number 20. How many meters of carpet 63 centimeter wide will be required to cover the floor of a room 14 meter by 9 meter? So the dimension, that is the length and breadth of the floor of the room, is given to be 14 meter by a meter. So let's say I am denoting a floor, that is a floor means the area of the floor will be equal to length into breadth of the room, which is given as 14. 14 is the length of the room, floor of the room, 14 meter, and the breadth is 9 meter. So the area of the floor of the room becomes 14 multiplied by 9 meter square, and this is 126 meter square. Okay. Now the question is asking how many meters of carpet 63 centimeter wide will be required to cover the floor of the room. So let's say the carpet required, let's say this be the carpet, let's say the length of the carpet required be x centimeter, and the width of the carpet is fixed, it is not changing, it is given to be 63 centimeter. So the concept is that if x centimeter length of the carpet is required, then the area, total area of the carpet should be equal to the area of the floor of the room. So area of the carpet, I am denoting, I am using some notation. So these are some standard notation normally used in higher classes, but so I am introducing them. Try to be familiar with this. So AC means the area of the carpet. So the area of the carpet then becomes 63 multiplied by x, this much centimeter square. So this is nothing but 63 x centimeter square. Now this area of the carpet should be equal to the area of the floor of the room. So we must have 63 x should be equal to 126. In all the dimensions, the width of the carpet is given as 63 centimeter, but the dimension of the room is given as a meter. So the area of the floor of the room was 126 meter square. So I think it is better we consider the length of the carpet required to be x meter. So let's say this be x meter, that is x meter length of the carpet is required. So the area of the carpet now will be, x multiplied by, x is in meter and the width is 63 centimeter. We have to convert 63 centimeter in meter. So this will be 63 by 100, this much meter square. So now we can say that 63x by 100 is equal to 126. So this implies x is equal to 100 divided by 63 multiplied by 126, this much meter, and this is equal to 200 meter. 200 meter. So A is the correct choice. So you must be very careful with the units. The dimensions or the unit of the dimensions of the floor of the room was given in meter, and the width of the carpet was given as centimeter. Now, while assuming the length of the carpet that is required, you can consider that to be in centimeter or in meter, and accordingly you should convert the area of the carpet either in meter square or in centimeter square. So with this, it comes to an end in solving the next set of 10 problems, that is question number 11 to 20 from the chapter of from the exercise 20G, which are objective questions based on the concept based on all the concepts of the entire chapter of mensuration. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the remaining 10 problems, which are question number 21 to 30, and that will complete the solution of all the problems of exercise 20G. So once the next video is complete, I will then solve the test paper sorry, the next test paper, which is test paper 20, which is kind of you can test your you can evaluate your understanding of the concepts of mensuration by giving this test. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.